Welcome to this linear equations pre-learning video. Now, for those of you who stumbled across this, perhaps some of my methods are going to seem a bit strange, but ideally, if you've been taught from me, the idea of a kissy-kissy will already have been covered in a previous video. So let's start with our pre-learning. Now, this is theoretically speaking to allow us to have a go at the maths methods pre-learning course. So, question number 1. Nice and simple. 3x plus 2 equals 14. Now, for those of you who remember, the thing is you don't try and split up the kissing, so the 3 and the x stay together, and as such the plus 2 is the one that changes place. So generally I put a circle around the plus 2 and I do an arrow to say that we're going to move it to the other side. So that the 3x is left where it is because that hasn't moved, and the 14 stays where it is as well. Remember, we do not like queue jumpers. If you're at the canteen and at the front of the queue, why would you want to put the plus 2 in front? So we move it to the back, but using the general idea of change the side, change the sign, that plus 2 becomes minus 2. There is something we can actually simplify now. We can work out what 14 minus 2 is, and so the 3x, which I'm going to move nearer to the equal sign just to make it look neater, is equal to 12. Here we go with that kissy-kissy. If you remember that between the 3 and the x is that kissy-kissy, that little thing we do between or at the end of my card to my mum, because I love my mum. Hi mum, if you're watching. So the x stays on its own and the 3 and the times move to the other side. Now obviously things get a little bit interesting because it's, well, the times can go before, but we'll stick to the idea of we don't like queue jumping. So the 12 stays there and the times by 3 becomes a divide by 3 on the other side, and so x is equal to 4. Well, at least I hope it's equal to 4, and a nice little double underline. So we have a general idea of, where my answer is. That seems like a fairly simplistic thing, but just so that you know, when I write my card to my mum, I'll generally say, hi mum, love you, and I'll put lots of little kisses at the bottom. And those kisses to me just signify a little time sign. So from this point forward, if you hear me talking about kissy kisses, it's nothing more than that's time sign. So let's look at our next question. And it is 4x minus 6 is equal to 2x plus 4. Now in this situation, whereas we've been using algebra before and we collect like terms, there's nothing to say that we can't do the same thing now. The thing is, we've got a 4x and we've got a 2x. So there's my 4x and there's my 2x. So they are sort of like terms, and then we have a minus 6 and a plus 4. Nothing difficult with here. I use the same concept, but what I'm trying to try and do is I'm going to swap things over the equal sign. Now I keep the equal sign pretty much in a line straight down so that I can keep things moving from one side to the other, but still with a general order. So what I think I'm going to do is I'm going to look at which side has the greatest number of x's. Well, hopefully we're all happy that the 4x is bigger than the 2x, so that's going to stay where it is, and I'm going to put a circle around my 2x, and I'm going to put an arrow to say, well, that's where I'm going to move it to. So if I'm collecting letters or pronumerals on this side, then I'm going to move the minus 6 over here. And again, remember that minus sign is really important. It belongs to the 6. It also needs to move. So what does that leave us with? Well, we already know that the 4x stays where it is. The 4, or rather the plus 4, is going to stay where it is. And what moves? Well, the 2x moves to the other side and becomes minus 2x. Why is it minus 2x? Well, it's a positive here. Although we don't write the positive at the start, we know that it's a positive. And what does the minus 6 do? It moves over to the other side and becomes a plus 6. I could put the plus in, and in fact for completeness at this moment I will, but is there anything I can now work out? Yeah, I know what 4x's take away 2x's are. They're 2x's, and I know what plus 6 plus 4 is. That's equals to 10. And just put my equal sign in there. So, oh yeah, hello, we go back to my lovely kissy-kissy rule. I know between the 2 and the x is my kissy-kissy, which means I can now work out what it is I've got to move. Well, I want the x on its own, so the 2 and the times is the thing that's going to move. And so what do we get left? Well, I have x is there, and the 10 was already in place. A times by 2 becomes a divide by 2, so x becomes equal to 5. Seemingly quite easy so far. Well, yep, nothing particularly complicated, just working on from where we were the last time. Let's throw some brackets in. Now again, those of you who know me probably realise that I don't actually call these things brackets. As far as I'm concerned, the brackets are exactly the same as a prison cell. So I think of these things here as being in prison. There's the 2 and the x, which are happily kissing, and the +4, which is the, friend who's been invited along just to feel particularly awkward while the 2 and the x are kissing. And those of you who realise the 3 is my prison guard. Now actually, the prisoners are inside the prison, and the prison guard. Now the only way they can actually escape is to kiss the prison guard. Yep, I know, those of you who are watching this from other parts of the world probably think I am actually delusional, but on the whole, let me work. So, to get out of the brackets, they have to kiss. So the 2x has to kiss the 3, and the +4 also has to kiss the 3. Well, when it kisses, it just means it's multiplied. So 3 lots of 2x is equal to 6x, and 3 times by +4 is +12, and that's equal to 24. So, interestingly, my brackets have now gone. Well, this is fairly simple again, so I want to get the x on its own, but unfortunately it's in the middle of kissing someone, so the gooseberry, or the thing that's watching, has to move. So I move the +12 to the other side and write out what stays. Well, the 6x stays where it is, the 24 stays where it is, and as we don't like queue jumpers, the +12 goes to the back and becomes -12. Oh, I've got something I can work out. 6x can just move nearer the equal sign for, neatness, and 24 minus 12 is in fact 12. Well, I need the x on its own, so unfortunately it's now time to split up the kissing couple. So I'm just going to write the kiss in to allow me to break it up. I'm so sorry. I hate breaking up young love, but in this situation, consider yourself broken up. So, the 6 and the times is going to move to the other side to leave the x on its own. The x stays. The 12 stays in place, and a times by 6 becomes a divide by 6, so x becomes equal to 2. Now actually, many of you probably will be sitting there thinking, well, is that the only way to do this? Nope. And the great thing with algebra is there's generally more than one way of doing something. So let's go back to restate the question, and I'll just write it out again. 3 bracket 2x plus 4 is equal to 24. Now, we don't actually have to be in a situation where the bracket kisses the 3 at all. What we can actually realise is between the 3 and the bracket is, guess what? A kissy-kissy! Life is so exciting. Everything in maths is about kissing, which sounds a little disturbing, but again, we'll just work with it and move on. Now, because there's a times, and that bracket is effectively connecting or keeping them all together in the prison cell, we can almost imagine this, that the prison guard, I'm afraid, is a bit bored over here, doesn't want to do it anymore, and actually wants to move over to the 24. Perfectly happy to be able to do that, because he can move wherever he likes, so long as it's the other side of that equal sign. Well, if the prison guard does a runner, that basically means the prisoners are free. I don't need those brackets anymore. So I can write everything that I haven't moved and just do times by 3 becomes a divide by 3. Oh, I've got something I can work out. So 2x plus 4 is equal to 24 divided by 3. That's 8 when I went to school. Oh, ouch. Bit of a mistake there. So let's just try that again, getting a bit excited. So let's just rub out at 24 and actually make sure that it reads the same thing. No video editing here. Let's just go real. Now, the 2 and the x are kissing. We've got to get rid of the gooseberry, which happens to be, in this case, the plus 4. So the plus 4 is going to move to the other side and becomes 2x there. 8 minus 4. So 2x is equal to 4. Ooh, I'm feeling confident that I'm going to end up with the right answer. Again, want to split up the kissing couple. So 2 times x becomes 2 kissy-kissy x. I'm going to want to move that times 2 over to the other side so that I can get the x on its own. And then so x becomes equal to 4 divided by 2. So x is equal to 2. Which is the better way of doing it? I don't know. It's down to preference. Obviously, the problem with algebra is there's lots of different rules that govern when you can do things. And we'll come back to some of those a bit later on, but at the moment this is just a general idea to give you a hint into what you need for that first section of the Maths Methods 1 and 2 book. So on to our next example. We do not like fractions at all. And obviously those of you who've had me will now realise that we can write fractions as bunk beds. Yeah, I know. Let's not go there. So we don't like things in bunk beds. We don't like fractions at all. And in many cases, the easiest thing is to try and get rid of the thing on the bottom. Now, we've got two fractions. So what we're going to do is we'll deal with it one at a time. And my general advice is, well, we know that this thing here is a divide sign. So altogether, this means divide by 4. And in maths, how do we get rid of a divide by 4? We times by 4. Woo! Now again, remember that when you are dealing with timesing or consistency, you have to times everything by 4. So let's just work this through. So an x divided by 4 times by 4 means that just becomes x. We now have to times everything else by 4. Well, minus 3 times 4 is nice and easy. It's 12. But what happens over here? Well, I'm just going to do a bit of a breakout calculation just so we can show. So we've got x over 2, and we're multiplying that by 4. Well, generally speaking, we know that we can only multiply fractions when they're both fractions, and we know that 4 is the same as 4 over 1. Well, I could do the hard work and go, well, 4 times x is 4x, and I can say, well, 2 times 1 is 2. Well, hold on a moment. I can see that 2 cancels into 4 2 times, and so I get 2x. That's certainly one way of doing it. Or we can also look at the idea of cross-cancelling and go, well, there's a 2 there, which cancels with a 4 in there 2 times, and 1 times 1 is 1, and 2 times x just becomes 2x. So again, different ways of doing things, but I now know that x divided by 2 times by 4 is just 2x. Ooh, very exciting. Now, going back to a previous example like we've done before, we can now see that we've actually got different letters on different sides, or the same letter on different sides. So I'm now just going to try and work out, well, what do I do with them? Well, I want the x's together. Which side has the greatest number of x's? Because that generally makes my life a bit easier. So we've got 2 x's here, and we've just got the 1 x there. So what I'm going to do is move that x over to the other side to give me that area of completeness. Now, this is the big trick. Remember, this minus sign here belongs to the 12, and so it stays with the 12. Ooh, negative numbers. Yuck. The 2x stays where it is, and a plus x moves to the other side and becomes a minus x. So minus 12 is equal to x. And just because convention generally suggests, we'd probably write that as x equals minus 12. Underline it. Yay, I am a genius. Well, let's see how we compare that with our next example. Ugh, lots of horrible brackets. We don't like that at all. I keep saying brackets and I mean fractions. Lots of fractions, but actually it works in exactly the same way. I don't personally like fractions. I can't stand fractions. I've got to divide by 2 here. I've got to divide by 3 here. Now, generally when you've got fractions, you'll start talking about having common denominators and combining them. I tend to like to think of things as, well, let's do it one step at a time. Let's get rid of this divide by 2 first. How do we get rid of a divide by 2? Yes, you times everything by 2. Absolutely everything by 2. Well, that's nice because that makes this nice and easy. That becomes x minus 3 because the divide by 2 disappears because of my times by 2. Let's put that in brackets for a moment. But what happens over here? Well, let's look at that. We've got 2x minus 4 over 3 times 2. Again, times 2 over 1, just for completeness. What do you multiply by 2? Well, here, for the top part, you multiply everything by 2. So 2x times 2 is 4x, and minus 4 times 2 is minus 8. So that's all the top done, and 3 times 1 is just 3. So I can now write this back over here. Don't forget the minus sign. And I'm going to come back to this in a second, because there is a bit of a trick with this question that actually throws lots of people. Now, I could get very excited because I've multiplied everything by 2 and just put my answer of 5 here and carry on, but then end up making a massive mistake, because remember, you have got to multiply everything by 2. So now that becomes equal to 10. Well, I've multiplied by 2, I've got rid of that divide by 2 there. What do I do now? Well, let's get rid of this divide by 3 by multiplying everything by 3. Well, if we multiply this, x minus 3 by 3, let's do a sub-calculation. I've got this x minus 3 times by 3. I'm going to put brackets around here just to make things a little bit more mathematically correct, but the idea is still the same. Multiply everything by 3. So we get 3x minus 9. So I can now write this as, because we're going to multiply everything by 3, I'm going to end up with 3x minus 9. That multiplied by 3 means I just get minus 4x minus 8. And again, remember, we must multiply the 10 by 3 to give 30. Now, if we actually continue with this and try and work it out, we're going to start hitting problems. And I said to be careful of this minus sign here. Part of the trick of this question, I suppose, is actually what we should really do is be putting brackets up here at the moment in time. And I'm actually just going to write them back here. Because now, hopefully, you'll start to see that this minus sign will now affect both of these terms, because this minus is effectively minus 1, which will multiply both things in a bracket. Had I not put the brackets in, you might have been confused to realise the minus sign just belongs to the 4x. So, well, there is a number 1 in front of this bracket, so I can just write that as 3x minus 9. But now minus 1 times 4x is minus 4x, and minus 1 times minus 8 is plus 8, and that's equal to 30. Well, we can now start collecting our like terms. 3x minus 4x is minus x, minus 9 plus 8 is equal to minus 1, and that's equal to 30. Well, the minus 1 I want to move over to the other side so I can get the letter on its own. I get minus x is equal to 30 plus 1, change the side, change the sign, and so minus x is equal to 31. And again, we generally don't like writing that, so we would normally multiply both sides by negative 1 so that we get x is equal to negative 31. Now, some teachers, I'm sure, would look at this and just, I don't know, probably collapse or write flaming emails on YouTube saying, no, 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 you shouldn't be teaching that way. Well, to be honest with you, with my analogy of bunk beds and whatever else, it works perfectly well, and I've yet to find a way it hasn't worked. So, good luck. One more question. Now, my handwriting absolutely sucks on this at the moment in time, but anyway, that's supposed to be AX, as in the letter A. I want to get X equals. I want to rearrange this so that I get X equals. Well, in many cases, that seems to be relatively simple, because I've got an X term on one side, I've got an X term on another, and we'll just assume that these letters here are constants, so they can be put on the same side. So, awesome. I've got AX and a CX. So, the AX is going to stay where it is. Why? Because actually, I want to try and move the CX over to here, and the plus B over to here. So, having the AX on its own and not moving means the plus D is also not moving. So a plus B moves over and becomes minus B, and the plus CX becomes minus CX. Now, I don't like the look of that because, again, we tend not to like to start things with a minus sign. So I'm just going to write that again as D minus B, and this stays as AX minus CX. We seem to have hit a bit of a problem, because this wants X on its own. I only want one X, but at the moment I seem to have two X's. Now, I particularly love this general concept because the Spice Girls, no, I am not a particular lover of the Spice Girls, but I believe they did a song that's two become one. Well, how do I make two X's become one? Well, nice and simple, we factorize. What is factorizing? It's taking outside of a set of brackets that which is common to a number of terms. Well, there's an X common here and an X common there, so I'm going to move the X outside. X times what gives me AX? A. X times what gives me minus CX is minus C, and the D minus B stay where they are. And what do you notice? Yay, 2 become 1. Well, I want the X on its own, so what does that mean I've got to move? Well, it means I've got to move this. Well, how do I do that? Well, remember, the X is stuck with the kissy-kissy. So that means the bracket is protecting all of that and says, well, treat me like one thing, and I can actually move it to the other side. Remember, it's a times by, so X becomes equal to D minus B, now divided by brackets A minus C. Just Let's rub that out so that we actually get that the right way. So it becomes A minus C. And again, that looks horrible. There could be all sorts of problems here. Well, what's divided by A minus C? Is it the B? Is it the D minus B? Well, that's why I don't particularly like writing things that way. If I'm going to do that, that was already there. So the D minus B was already there. And I divide that by A minus C. And ladies and gentlemen, that is how X becomes a loner. Well, that's the end of this. I've probably talked for about 45 minutes. You're probably bored. So I'll move on to the next section on the next video. Hopefully it's made sense. Have a good evening.